All right, so we're going to look at the area of a triangle. So I've been trying to listen to what my students have been saying about their understanding of these types of things. And generally, they like the formulas, but then sometimes we get in this situation where we know the formula, but we just don't know how to apply the formula. So if we look at the area of a triangle, we can say that it's equal to BH over 2, okay, which means what it's strictly speaking, what it means is the base multiplied by the height divided by 2. And it can get a little bit tricky because, well, what is the base and what is the height? So you need to be very careful. So what I wanted to do in this video is explain that in a little bit more detail and sort of explain what these animations are going to do here. Some prior knowledge you're going to need to understand this is the area of a rectangle, which is given by length times width. And I think the wording around this topic can sometimes make it a little bit confusing. We've got bases and we've got heights, we've got lengths and widths. What's important is the number that you're multiplying by, right? You're multiplying by the numbers that are relevant to the problem, right? If you get bogged down in this idea of length, for example, a lot of my students think that the length has to be the longer side compared to the width. Generally speaking, that's true, but that kind of thinking can get you into all sorts of traps. Because all that really matters is you multiply this dimension by this dimension, whether you call it the length or the width, doesn't really matter, right? So let's drill down into this idea a little bit more. If we look at these triangles here, if we talk about the base and the height, you'll notice that these three triangles are actually exactly the same triangle, right? They're all identical, but obviously different colored. And we've obviously got this line here that's different in each one. This line here is called an altitude. So if we consider this point here, if we drop an altitude, that means that it's perpendicular to this line here, which we're going to call the base. So the base in these examples is the one that has the right angle associated with it. And so what I want to point out is the base times the height needs to be the base multiplied by the perpendicular height of the triangle. So if we rearrange this as well, you can see why that's relevant. Let's look. The base is this length here. The height is this height here. And so you'll notice just by that animation there that the base times the height divided by 2, well, that's just half the area of the rectangle. So when we think about the height, we really need to think about the height of a relevant rectangle. So you can see here, we're essentially just finding the area of this rectangle, which is length times width or base times height, same idea. And then you half it because you only have half the area for a triangle. Similarly, over here, I encourage you to sort of see if you can visualize how this is going to sort of transform into a rectangle. So if we start to rotate that, we can see that we get this. This is our base now. This is the base, and this is the relevant height. Again, remember, these are the same triangles, but this is now the base, and this is the relevant height. So if you wanted the area of the triangle, you could multiply this base by this height. And finally, we've got it over here. We've got, if you rotate these in the right way, you get your rectangle like this, where this is the base now, and this is the relevant height of the rectangle. So you need to be very careful when you're doing these problems that you're making sure you get the right base and the right height. You can't just pick whichever numbers you like or whichever ones are convenient. It needs to be the perpendicular height to the base. Perpendicular meaning at right angles, right? So let's just step through one example. Let's be clear. So height, base, in this case, height, base, height, base. And let's just do this example. Let's just give them some numbers. Let's say that the base in this one was 10 centimeters and the height in this one is 4 centimeters. Let's just write the formula. So BH over 2. So that's 10 times 4 over 2. So you can put that in your calculator. 10 times 4 is 40, divided by 2 is 20. So the answer is 20. But I think here's also a good time to review our number properties, because sometimes when we're dealing with fractions, we can actually write it a little bit differently. We could also write 10 divided by 2 multiplied by 4. 10 divided by 2 is 5, times 4 is 20. So we can see that that's a good number property we can apply there. We could also do it another way. We could do 10 multiplied by 4 divided by 2. 4 divided by 2 is 2. 10 times 2 is 20. So we get, in any case, that our answer is 20 centimeters squared. So just a bit of a review of our number properties there. So that is the area of this triangle. Now remember, the base length and the height might be different in this, but you'll still get an area of 20 centimeters squared. So very important that yeah, you're just taking the relevant measurements off the diagrams. Let's try a problem. See if you can apply that knowledge. So find the area of this shaded region. So you can see we've got a triangle here, shaded in blue. See if you can find the area of that, and let me know how you're going. Good luck with all your work.